page. Example 7 says, let f and g be continuous functions for all x in the closed interval 2 to 5, with particular values of f given below. Right? The question is f prime positive, negative, or equal to 0 on the closed interval? All right, well, let's look at the values of f. We see that x is going from 2 to 3 to 4 to 5, so we just got this constant change in regards to x. What's happening with our function? Well, our function starts at 7, it increases to 9, then it increases to 12, then it increases to 16. What's going on with our change here? Is the change, in other words, the derivative, going to be positive or negative? Well, we increase by 2, then we increase by 3, then we increase by 4. In essence, our function is increasing, and an increasing function means a positive derivative. Now, what about f double prime? Is that positive, negative, or equal to 0? Well, here's the situation. F double prime looks at how is the change changing. Is the change increasing, or is the change decreasing, or is the change remaining the same? This is where it gets a little tricky. Again, look at what we just wrote over here. We know that these numbers are positive, and that's why f prime is positive. But how are these numbers changing? First it was 2, then the change was 3, then the change was 4. The change is increasing from 2 to 3 to 4. So that means we have an increasing first derivative, and therefore we have a positive second derivative. Let me give you another way of looking at this if you're not quite sure. Let's make a quick graph of f. Right? So we've got our x-axis here. Over 2 up 7, just put right there. Over 3 up 9. Over 4 up 12. Over 5 up 16. If we were to graph these points here and sort of connect the line, we can see that we're definitely increasing, and we can see the concave up curvature happening as well. That verifies that f prime is positive and f double prime is positive. Now we're going to go in reverse for part C. G prime is negative, G double prime is positive. So what are some possible values for G? We're going to write them in here in the table on the right. And so you know there are an infinite number of answers right here. It's just a matter of making sure that we have each answer that we put down is in the correct range of answers. So for starters, we see that G prime is negative. This tells us that G is decreasing. So whatever number we put here has to be less than 16. Okay. We also know that the rate at which G is decreasing is actually going to be increasing because the second derivative is positive. All right. So the rate of decrease is increasing. And this is kind of difficult to look at. We know the function's decreasing, but the rate at which it's decreasing is increasing because this second derivative, this rate of change, the second rate of change, tells us how is the change changing. Well, because the second derivative is positive, the change is increasing. What's the change? The change is the rate of decrease. That's our first derivative. So what does this mean? Well, it means that we have to drop our numbers down. Our numbers have to decrease. But they should not be decreasing by as much each time. So let's just pick a nice round number. Let's say that we decrease by 5 units, okay, for our first one. We're going to decrease, and we're going to decrease by 5 units. So that drops us down to 11. All right, we decrease by 5 units. Now, the rate at which we decrease must increase. This means that we can't drop by 5 units again, nor can we drop by 6 units. We have to drop by an increase. So over here, notice we increased from 2 to 3 to 4. We have to increase again. Let's increase our decreasing rate by 1 unit. Let's increase it up to -4. Keeping in mind that -4 is bigger than -5 because we're to the left of 0 on a number line. That would put another answer as 7 for G of 4. Then we need our rate of decrease to increase again. Again, the number has to be negative because we have to decrease. We need a number smaller than 7. Okay? But the rate at which you decrease has to be larger than negative 4. Well, let's just go with negative 2. So 7 minus that 2 drops us to 5. Okay? So in essence, what's happening? We have a negative derivative, so our values must decrease. And they do. 16 down to 11, down to 7, down to 5. But the rate at which we're decreasing must actually increase. And we were decreasing at a rate of negative 5, then negative 4, then negative 2. So we have our correct potential answer here. And there are tons of answers here. We don't have to decrease by 5 initially. We could decrease by 2. But then we have to decrease by less than that. Or rather, the rate of decrease has to increase. So this would have to be like negative 1, and this would have to be like negative 1/2. Again, just quickly looking at the picture here, all right, if we're 2 units over and 16 units up, then we're 3 units over and 11 units up, so it's a pretty large rate right there. And then we're 4 units over and only 7 units up, so right around there. And then we're 5 units over and 5 units up. Not drawn to scale here. But what we can see here is we have this decreasing function, which is concave up. Well, g prime is negative, so our function should be decreasing. G double prime is positive, so our function should be concave up. And we can definitely see the U-shaped curve there.